Hello, and welcome to the 12th episode of the weekly Google Cloud Platform podcast. I'm Francesc and Mark, and I'm here with my co-host, Mark Mendel. Hey, Mark, how are you doing?
I'm good, thanks, Francesc. How are you doing?
Pretty good. Very, very excited about this episode. We're going to be chatting with some of my friends.
Some of your friends. Hey, they're my friends too.
Yeah, so we're going to be chatting with two of our colleagues, actually. So Bret McGowen and Tsang from the Google Cloud Platform Advocacy team.
Yep.
About Google Cloudspin.
Yeah, that should be pretty exciting. I've been involved, at least peripherally, with Cloudspin, setting it up and helping run it. We've talked about it a few times, so it's going to be good to get into sort of the details of what it is and what it does and how it works and stuff.
Yeah, it's a really fun project. It's a really fun project to run. It's a really fun project to see working. And it was a really fun project to develop. So I hope that you will enjoy the interview.
Definitely.
But before that,
let's talk about a cool thing of the week.
Okay, so the cool thing of the week is related to Cloud9. Could you tell me a little bit more about what Cloud9 is?
So Cloud9 is an IDE and development environment that you can use, funnily enough, in the cloud. So rather than, say, installing like IntelliJ or Vim or Emacs locally, it's a fully web-based environment where you can build and write code.
Nice.
Which is pretty cool. They recently released a plugin specifically for Google Cloud Platform.
Oh, nice.
Which is very cool. So right now it's in beta, so it has a limited sort of functionality, but it gives direct integration for Java applications running on Managed VM. In the coming weeks, they're planning to add some more bits and pieces to it so that you've got some more functionality and features and languages. But it was really cool. You should watch the video and have a look, but you can see someone like go in, it's got gcloud installed automatically for you. You can pull down like a little starter project and it loads it up. You can preview it in there. You can run it from in there. You hit deploy, it goes up to the cloud, goes directly to us, so it can run from in there. It looks like a really cool thing. So maybe if you're traveling with a Chromebook or you don't want to install stuff locally, this could be a really nice way to develop.
Yeah, I really see it as a very good option if you don't really like using like Vim and tools like that. You really want an editor. That's a kind of thing that only normally you get to use locally.
Yeah.
So they're basically providing that on the cloud through a browser.
What's also nice about it, like if you think about it, when you're building stuff, like it means you don't, like if maybe you have a low-powered machine or a slow machine or something like that, connect it to the cloud, use the power of their platform and the speed of their platform and their network.
Yeah.
You can push big Docker files around, all sorts of things like that. It's actually kind of neat.
That's actually a very good point. And maybe we should also talk about it next time. But when you're building Docker files, etc., and you're downloading so many dependencies.
I know where you're going with this.
When you do it over a hotel Wi-Fi, it can be fun. So yeah, here with Cloud9, you avoid that problem completely. So that's pretty cool. Yeah,
that's pretty cool.
Nice. So I guess that it's time to go talk with Ray and Bret.
Let's go do that then. Today we have a couple of very special guests joining us this afternoon. We have Tsang sitting across from me as well as Bret McGowen. How are you both doing today?
Good. How are you?
Good. I managed to only slightly ruin your last names, I'm hoping. Only in a slightly way. So we're talking today about a fun project that we've sort of demoed around the place called Google Cloudspin. And I know it's a project that Francesc, you've been involved, Ray, you've been involved, Bret, you've been involved, several other people. Would love to talk to you about it. But why don't we first find out a little bit about Ray and Bret. Bret, you're closest to me right now. Why don't you give us a bit of your background and who you are and what you do?
Sure, yeah. My name is Bret McGowen. I'm a developer advocate for the Google Cloud Platform. Before that, I was in Texas working at Rackspace, so I have a little bit of a cloud background. I was a software engineer my whole life until I came to Google and started working in developer relations and developer advocacy. And I'm actually in the New York City office. It's kind of cool to be here in San Francisco in studio to meet with you guys.
Cool. Wonderful. Ray?
Yeah, my name's Ray. I'm also a developer advocate. I'm also from New York, and I haven't always lived there. I actually lived in Southern California before. And I've been a developer and an architect all my life since I started to work. And I've been in New York for about 2 years, and I've been through two of the worst winter ever. until this year. So I'm feeling a lot better about New York now.
Wonderful. All right, so we're here to talk about Cloudspin. Seems like I'm going to be directing things because I'm the only one in the room who wasn't involved.
Yep.
So what exactly is Cloudspin?
Okay, so Cloudspin is basically just a bunch of phones pointing at you. imagine that you have 20 phones or so, and they are all on a semicircle, and you're on the center.
Yep.
So they're all the same distance from you. And at one specific moment in time, they will all take a picture exactly at the same time. And then what we do is we take all of those pictures together, and we mix them into one single animation. Now, when you look at that animation, basically it looks like a camera is rotating around you, but while it's rotating, the time stopped because you're not moving at all. And if you're jumping, you're kind of flying. Or if you're going back to avoid a bullet,
like a Matrix style.
Exactly. It could look exactly like the Matrix, but without budget.
and time.
And yeah, with a budget, no time. We had, I think it was 3 weeks.
Just about 3 weeks, yeah.
About 3 weeks, taking into account that Bret was actually taking vacations in the
So are you,
Francesc. And so was I.
That was the fourth week.
Not even 3 weeks.
So not even 3 weeks. And we wanted to build a cool demo. And yeah, I think it worked pretty well.
Yeah.
So I know it was the three of you. Was there anyone else who was working on the project as well?
Yeah, Kathy Cam, who was our program manager in Seattle. She kind of drove everything forward, and for as zero budget we had, what little we could get, she took care of that. So we're grateful for that.
Yeah, no, that was pretty awesome. Basically, the work was divided into, I was taking care of the cloud part of it, so all the server side and so on. And then you two guys were more like Android.
So Bret was working more on the Android, and I kind of floated around. I guess I didn't do anything.
All right, good. No credit to you, Ray. Wonderful.
There was all the stuff about actually making it work, you know.
Yeah.
and Kathy actually took care of building the whole thing, like making sure that it was built for all the demos we wanted. So that was pretty good.
That's cool. So all right, so let's go back in time. Let's sort of go through this, like a flashback. So all right, inception point. Like, whose idea was it? Let's have some controversy. Let's have an argument. Where did this thing come from?
So I'm gonna say it was my idea, but that's how I remember it. But my memory is really bad, so probably it's wrong. So basically, we wanted to build a cool demo, and we were discussing any ideas, basically, like doing what's it, a brainstorm? Brainstorming. There you go. Brainstorming session we were talking about. And I think that was Kathy that brought up that YouTube was doing slow-mo. So slow-mo videos where you could slow down a video and make really cool videos. There's basically, you do frame interpolation to make it look like you recorded with a high frame camera. But instead of doing that, we thought about what could happen if you slow down the time so much that you stop it, and then you actually move the camera. So that's what we wanted to do. Basically, like stopping the time and moving the camera. Unfortunately, even with the cloud, you cannot really stop the time. So we decided to basically do it with a bunch of cameras.
And off-the-shelf cameras, not like
off the shelf.
Yeah, not the expensive cameras.
Actually, our idea was, since at Google we have a decent amount of phones around, we wanted to use the first plan was Nexus 5 phones?
Nexus 5? Yeah, we had to figure out which phones to use.
Yeah, but like something cheap.
Nexus 5, something cheap.
Yeah.
And something that everybody may have.
Yeah.
Okay, so this was in theory a project that other people could build themselves if they wanted to?
Yeah, so one of our goals was to open source the code, to use all off-the-shelf components, because we want people to actually be able to set up CloudSpin at home, to learn about the cloud, and then maybe kind of invite friends over. Everyone brings a bunch of phones, you set it up in a circle, and you kind of create your own CloudSpin. So from the beginning, our goal was to actually make it so accessible that, as accessible as having 20 phones is.
I mean, if you have 19 friends.
Yeah.
We can have it work with five phones.
Yeah.
Yeah, you can do it with small CloudSpin rigs.
Yeah.
Okay.
And actually, talking about open sourcing the code, if everything goes correctly, by when this episode is published, the code will be open sourced.
Really?
So we will have links in the show notes. And if it's not the case, then I'm sorry, because I didn't do my job.
Should we delay the podcast until...
this should happen. Yeah. Pretty confident about
Well, they could just start and watch it, and then they'll see.
Yeah.
It should be.
Okay. All right. That's faith. That's courage in face of adversity. I like it. I like it a lot. Okay, that sounds cool. All right. So you're building a thing. It needs to take a bunch of photos around in sort of like an arc so that you can get them all together and I guess stitch them together so that you can do like an animation or something. Where did you start, Ray?
Yeah, so the first thing that we thought about is, hey, how hard could it be, right? This has been done before. You can do this with professional cameras really, really easily. For example, you should be able to have all the cameras to take the photos at exactly the same time from all the different angles. But because we chose to use just Android phones, we actually ran into the first hurdle, which is what we've been told by other people. It's like, hey, that sounds really hard to do, like almost impossible. In fact, one of the person told us like that's impossible because when you tell the phone to take a photo, there's something in the hardware that may introduce some kind of delay. And so if you have 19 phones that's all trying to take a photo, they could also all be taking the photo at different times. So we have to solve that problem the very first time. Yeah. And that was difficult to think about it. And to software engineers, I think the first thing that most people think about is, well, how can I solve this with software? How do I use, say, machine learning or vision APIs or whatever to kind of figure out, how high did the person jump, or are there any other things that we can extrapolate from the image itself? But that all turned out to be really hard to do. And we only have 3 weeks. So I'm not a computer vision scientist myself. I don't think anyone here is.
Nope.
Anyway, so we didn't know how to do that, right? So,
just on weekends.
Yeah. So we spent time to figure out how to solve that problem, and eventually we ended up with a solution that is actually being used in some of the video industry, right? When you're trying to record videos from different angles, you have this clapperboard where you synchronize all the cameras by the clap of the clapperboard, visually and also by the sound. And so what we ended up doing is just to use audio signal that we can feed into every single one of these phones. And the phones, rather than taking a photo, we're just going to be taking a video. And when you jump into the midair, somebody is going to press a button and generate a tone that gets fed into the video recording streams of every single phone, and that will mark the same moment in time in every single video.
Yeah. So the main idea was to, instead of using something from the image, just like making a noise.
Yep.
And before we had the cables, it was actually pretty fun because we tried just by jumping and clapping. And that could also work because basically what we do is we just identify the noisiest frame.
Yep.
And the noisiest frame, even if you count it by the number of frames changes for every video, because all the cameras start the video at different moments, the sound arrives at all the phones exactly the same time. So we use that as synchronization.
It makes it for some pretty amusing moments with other people in the same office because they would walk by a conference room and we'd be jumping up and down yelling "Hiya!" And they're like,
I remember that.
What is going on in that room? And we never told them. So to this day, they have no idea what we were doing.
That was fun.
Yeah.
That's great. Okay, so you've got your phones. They're taking a video. Then where does the video go? Who wants to take it?
Sure. So the first thing it does is each phone uploads it to Google Cloud Storage. So we got to put it somewhere. We got to put this video up for processing. So we use Google Cloud Storage, and then we use something called object change notifications. So Cloud Storage will actually call the next endpoint, the next step in the process automatically for us.
And that's an HTTP call?
Yes.
Okay,
right.
cool.
And so it kind of has this JSON payload that describes like where the file is, what its MIME type is, and things like that. And that was pretty nice because that actually let Ray and I work on the Android things independently, and all we had to do was upload it to Cloud Storage. And Francesc could actually take care of configuring the next API endpoint. He could do that independently. And so we didn't actually have any discussion of like what does our API signature look like or where does that work. All we do is upload it to Cloud Storage.
That was actually pretty interesting. There was not really an API. It was just everything through Cloud Storage.
It was more like just give it to Francesc.
Yeah.
We're done.
He will take care of it.
And then literally I went on vacation.
So it seems like a good plan.
Yeah.
Okay, great. Okay, so we've taken our video. It goes into Cloud Storage. We have an object change notification that goes to something. I'm guessing the next step is like to pull out the image or something like that?
Actually, before that, what we wanted to do was we want to make sure that once an image has been uploaded, one video has been uploaded, we won't miss it. We need to process it. So what we did was put that message into Cloud PubSub.
Okay.
So just like manage a way of having tasks. So basically, we talked about it.
We did. We have talked about it previously.
Some previous episode.
Yep.
The goal being that once it's in there, then we'll have some workers that will extract the job, the frame from the video. Once we do that, the cool thing is that how many workers we have, that's not important. So architecture, it's much easier to manage. If we need 20 workers, well, we just start 20 workers. If we don't need more than one, well, we can have only one. So that's pretty good. And then what it's going to happen is that message will include just the name of the video, basically where to find that video. And every worker it will go find that video and then extract the frame using MoviePy, which is a Python binding over FFmpeg. FFmpeg? Yeah, FFmpeg, which is an amazing library that does basically everything you could imagine with videos.
Cool. Okay, so we've gone phones, storage, object change notifications, PubSub. Now we're going to an extractor, some kind of worker that is picking up from the topic on the PubSub. Okay, and then the images go, I'm guessing, back to storage?
Yep, back to cloud storage.
Okay, and at that point, do we go back to another object change notification?
No, actually, instead of doing that, we could have done that. But instead, what we did, since we were already using Cloud PubSub, it was just putting the next task into a different topic. So we have a topic which is videos that are ready to be processed. And then another one which is images or frames that are ready to be stitched together.
Okay. So all right, cool. So that's going that from, PubSub to the extractor. And then back into PubSub, or just different topic?
Yeah.
Different topic. Okay, where does it go from there?
To a different job. This job, what it's going to do is going to just receive all the notifications of frames being ready to be stitched.
Yep.
And it's going to wait till it has all the frames for a single picture. So for one jump, basically. So one jump could have like 20 cameras. So we're going to have to wait for those 20 frames to be ready to generate animation.
Okay.
Yeah.
So how does it know that?
So we use Firebase to coordinate not only that, but actually just kind of in general. So Firebase is kind of sort of a real-time database. So we use it for our visualizer, so it can track like the state of all the cameras. The cameras actually use Firebase to coordinate amongst themselves. So when you say like, okay, everyone start recording, it just writes a value, a timestamp into Firebase.
Okay.
All the phones are like listening to that. They're sort of subscribing for that change. And like very, very quickly, within less than a second, all the phones automatically get that notification. And then throughout the whole process, we're basically just updating Firebase database. And every listener can see those changes as they happen.
Okay, so tell me, all right, so Firebase allows you can push data into it, and it synchronizes that data across all the things. All right, so you're using that to coordinate all the phones, as well as provide a visualizer, because I'm guessing that's got webhooks as well, so like on the browser. Awesome. We should have Firebase on the podcast at some point soon.
Yep.
Hopefully. And then, okay, so then Firebase will tell you, okay, we've got 20 images, they've all been processed and they're ready to go. Now they have to go to something to put them together?
Yeah, so that's going to be a different worker, and it's going to also use FFmpeg. This time directly. No need to use any extra libraries, basically 3 or 4 commands. So since I'm so special, instead of doing a bash script, I wrote a Go program.
And the Go program does four batch codes, right?
Basically.
Oh, really?
Basically, what it does,
nice.
it goes, downloads all the frames for an image, then calls FFmpeg for different commands. Where basically what it's doing, it's just putting everything together as a video, applying frame interpolation to make it look smoother, and then generate a GIF from that video, and then upload that video back to cloud storage.
Okay. One interesting question, though. So how does the information for the synchronization from Firebase get to your program to tell you all the images need to be stitched together?
So actually, I tried 2 different things. One was getting notifications directly from Firebase. So on Firebase, you can watch a value and be like, oh, something changed, and you react to it. But instead of doing that, I decided that it was better to just wait for the notification from PubSub. So every single time I get a notification from PubSub saying this frame is ready, I update the Firebase values. And once all the Firebase frames, all the frames on Firebase are being set to they're ready, then I generate the GIF and I upload it.
So basically, you get a message saying, hey, this one's ready. And then you send it to Firebase and you say, hey, Firebase, how many are ready? And it says 1 out of 20. And you're like, okay, then I'll send the next one and so on and so forth until it says 20 out of 20 and you're good to go.
Yep, exactly.
Cool. Now, I believe there's one final step.
Yeah.
To share.
There's the sharing part.
Go on, right?
Well, so to share, we thought about the different ways or different channels to share it. But I think one of the most popular that for our target audience was the Twitter,
Yeah.
right? So we wanted to share on Twitter, and we also wanted to share on email. And we actually have to do a lot of work. Francesc had to do a lot of work to make sure that the GIF that's being generated is under a certain size restriction. Otherwise, Twitter will reject the image upload. So I don't know. There are quite a few things that you have done there to reduce the size of the GIF, right?
Yeah, basically.
Is that GIF or GIF?
I could say GIF.
Whoa,
You can
fighting
say
words.
GIF if you want to be wrong.
I'm on the record as GIF.
No, go ahead.
Yeah, so basically what I ended up doing was changing the FMPEG commands to generate images of lower quality just at the end of the GIF. So basically that means that when I'm uploading the GIF, we're gonna get a lower quality. And if you go, actually we have at Google Cloud Spin, that's the Twitter handle. If you go there, you're gonna see all the GIFs. And you're going to see that the quality is not that good. Basically, what I do is reduce the quality and also the amount of colors that I'm using in the palette, which means it doesn't look as good, but at least it works. Because otherwise, I could not just send it directly to Twitter. It could get rejected.
So there is actually a movie file somewhere.
There's a movie file. There's an MP4 that we don't even keep, actually. We just use that as a intermediary step to generate the GIF. But we're considering on fixing that.
Okay. I think we can keep that in and send the MP4 out.
Yeah, we should send it on the email. Yeah.
Awesome. Now, I know also, because I was at an event where you were doing this and playing around with it, there's some image stabilization I think you've been doing.
Yeah, the image stabilization. So as soon as we started actually taking pictures, we realized that one of the most important things is all the phones have to be pointing exactly at the same point with millimetrical precision.
And
this
the
is
way
hard.
that we do this is very rudimentary.
Yeah.
Very scientific.
And for those who are listening, the way that we do it is we find a stick and we put it into the center of the circle, and then we try to align the camera to that stick.
Actually,
Technical.
we're much more pro than that because we added a little.
We had two markers.
Two markers
Yeah,
on the
crosshair-
camera.
crosshairs,
yeah.
Two cross arrows on the camera to actually be able to align.
And then we'll tape on the pole to like where the crosshairs go. So
Yeah.
it's pretty fancy.
Yeah, and we do this every event that we go to,
Yeah.
and we always are able to find a stick somewhere.
Yeah.
I've personally, I know I've seen two tables resting on one another.
Yep.
Yes.
Coffee tables,
I've seen that.
high tables.
I've seen a lamp.
Yeah.
Yeah, I've definitely seen a lamp. Just random bits of tape, kind of taped to various different things.
Yeah, blue tape.
Well, at one event, I actually used a human being. I said, can you stand very still and don't move? And he said, okay.
Which event was this?
That's pretty good. But yeah, so we decided, we realized that it was probably not the best solution. And we still need to do that, really. Because if the cameras are not well aligned, the quality of the image at the end will not be good. But even if there's a little bit of variation, that should not impact that much the quality of the image. So I ended up applying, as part of FMPEG, because FMPEG does everything, really. I added stabilization for the images. The weird thing is that it's actually not done for what we're doing. Stabilization is for a camera that is shaking, but pointing to different places. So the camera is not moving that much, it's just changing orientations. While what you're doing is the other way around. It's actually pointing at the same thing, but moving and jumping from one side to the other. So the algorithm is kind of weird and sometimes creates some weird stuff, but it's fun.
Cool.
Yep.
I know that came like towards the end of the project. Were there any like other tweaks that you either have done or are interested in doing in the future? Updates, improvements?
Something that I think that blew my mind was, I think it was Bret did it. The fact that we could change the how much light on the videos we could get.
On
all the
The ISO and
Oh,
etc.
ISO.
yeah, we did that,
That was
to
really cool.
make sure that we can get the best lighting on the video.
Yeah,
that's
so if
being
you can
recorded.
explain how we did that, because that blew my mind.
Yeah, well, we did it using Firebase. And part of the problem is we were going to be taking this to a bunch of different venues that we didn't know what the lighting conditions were. So we did it at an event where it was so dark, it was basically like inside of a cave. And then we, literally 2 days later, we did another event where it was essentially outdoors. And so we didn't want to have to like recompile the app each time. So we just had each Android app watch Firebase for the ISO and exposure settings. And so we could set it in a control tablet. And you can play with them and you can see all the screens, the viewfinder in the back. You can see it getting brighter and darker.
Oh, that's what you were doing when we were doing it together.
Yes.
Okay.
So you just have to adjust one place, and then all of the cameras get synchronized with the new settings, and you can see that across all the cameras.
That was really cool. Basically, Firebase is used everywhere, even to decide what's the ID for every phone. We just start with one, and you start just clicking around the phones, and everything just works very well.
And you know what else that was really good that we have done is, like, because we're using Firebase and we're developing this demo to just make it work in the first place, we didn't really think about how to visualize this with the audience. Like, how do we show this to the audience? Because you could actually just go and take a photo and without seeing how things are being done or taking place behind the scenes. So because we're using Firebase to store all of these state, it was really easy to just get that stream of data, pull it down into a HTML5 page, and just being able to visualize that. And then we are able to build this visualization tool in about, I don't know, like half a day.
Yeah, that was awesome.
The POC, so that people can actually see on the big screen of what's taking place behind the scenes in the Google Cloud platform.
It went from watching logs on the monitoring page to all of a sudden having like images and showing you what is being extracted, what is being uploaded, and so on in like half a day.
Animations and everything. It was pretty cool.
That was really cool. Yeah.
There was another change that you made. I thought was really good because initially we were it's the audio detection algorithm. So the video has this audio marker inside, and the algorithm that was detecting where the audio was the loudest was written by a intern that was working with us initially, and he's brilliant. Matt is really smart, and we used that for the very first couple of versions. But that has issues, right? So Francesc changed a few things.
So there's a funny story there, which is first time we tried to run it in New York. I don't know if you remember.
I remember.
The night before, trying to make it work, and nothing could work. Absolutely everything could just fail. And I didn't really understand why. Like, it could just take random frames. I don't know why. And after reading the code for quite a while, I realized that instead of comparing, like trying to find the first frame for which the average noise was higher than 3 times the average of the rest, which was what we were using, we actually were checking the standard deviation, which somehow worked every single time at the office.
Because the noise level at the office.
Because there was no noise.
Yeah.
So when there's no noise, actually the standard deviation of the average pretty much worked. But as soon as you start having noise, all of a sudden nothing works. Right. So that took me like 1 hour of reading 3 lines of Python until the moment I understood what's going on.
And in the end, I think what worked best was just getting rid of the average and just take the absolute max. Right?
Yeah, at the end, what I did is just like I just put basically what I do is I get for every single image frame, I have a bunch of sound frames because the frame rate for the audio is much faster than the frame rate for the video. And I do the average for all the audio frames for every video frame.
Right.
And then I find the one that has the biggest amount of noise.
Right.
And that's it. And that works really well. Yeah.
Keep it simple. Wonderful. Kind of going to be wrapping up soon, but is there anything else that you want to mention about CloudSpin, something interesting or anything like that?
So I do hope that people check it out in GitHub, set it up, and can give us feedback on the code. It doesn't have to be that fancy. When we travel around with it, we sometimes have a big wooden or metal constructed rig and a fancy backdrop and 20 phones in a circle. But our first prototype was actually using literally selfie sticks. So
I remember that.
I don't know if you've ever tried to use a selfie stick as a camera tripod, but it is the least stable way you possibly can hold up a half-pound phone. In fact, Ray and I were constantly diving on the floor to save this thing from smashing to the ground, and have to explain to our boss why we just broke a $600 phone with a selfie stick.
And to this day, we haven't dropped a phone on the selfie stick.
Yeah, well, thanks for jinxing it. But,
knock.
But yeah, it doesn't take much to set up. Like we use selfie sticks, we use these weird clamps we would hook to the end of the table, just kind of anything we could to organize these phones in a row. So I really hope people will check it out. There's a big walkthrough, walks you through how to set it up. You can learn a lot about Google Cloud Platform through it, and then hopefully people will have fun with it.
Yeah, we have 3 blog posts on the Google Cloud Platform blog, so we will put a link for those in the show notes. Yep. And there's also 2 episodes with Coffee with the Googler.
Yep.
So yeah, we'll also have the links where basically you can actually see the real thing actually working with Lawrence Moroney jumping around. That was lots of fun.
Yeah, and you can find all of this information too just by following us on the Twitter account at Google Cloud Spin.
Yeah, at Google Cloud Spin you will find
and there's
it
a
too.
link you can click on that has all the links.
Yeah, and if you want to try it, we're gonna have it GCP next. Where are we having it? I know that
They're like a bunch
South
of
by
places.
Southwest.
South by Southwest. We're gonna have it.
GDC, it looks like as well.
GDC in San Francisco probably. GCP next, I'm not sure. No,
Yeah.
Yeah.
don't think
DroidCon?
so.
we don't know yet.
DroidCon?
I'm not sure.
Okay.
But yeah, we're gonna have it in a bunch of places. So if you ever
If
see
you're
it
around, it's probably going to be there, I think.
just go sit and jump, take a good picture, and you're gonna see it. There's people doing really weird stuff. One of my favorites is actually Bret and you.
Yeah.
The force choke.
The force choke.
Yeah, Bret has me up in the air.
Yeah,
using the power
Mark
of the
is
force.
jumping there on the
Yeah,
air.
you'd think I was jumping, but really, he was just holding me in the air by the power of the force.
That was a great, that was a great
was
animation.
Really cool. That was really cool.
Wonderful. Well, thank you so much for joining us. We really appreciate it.
Yeah, thanks, y'all.
No, thanks.
Yeah, thank you.
Thank you very much.
Thank you so much to our 2 colleagues, Bret and Ray. That was a really, really fun interview to do.
Yes, it was.
Yeah, I hope that you enjoyed it. And yeah, if you're interested in learning more about it, don't hesitate. We're gonna have all the links in the cloud in the show notes. Just go read them, watch the videos, read the blog post, and if you want to know more, just go on GitHub. The code should be there by now. Okay, so let's go. Before we end with the episode, let's go with the question of the week.
Yep.
And the question of the week is actually about Kubernetes, one of our most beloved projects.
And very popular podcast.
Very, very, yeah, that's actually one of the most popular podcasts. Yeah.
Yep.
So the question is, okay, I want to run one container, or actually one pod, one job, per machine, per host. So my first solution for that was, if you have like 4 hosts, you say in your replica controller, I want to run 4 pods. But then what happens if one of those nodes disappears? You end up with one of the nodes running 2.
Or really, you actually have no guarantee where those pods are going to end up anyway.
So basically, you could maybe try to trust it, but like, if you're lucky, might work, but like that's really not a good solution. You're gonna end up with either too many or none
at all.
Yeah, or none at all actually. So that's not really the solution. So I'm assuming that you know the answer for this one.
I do know the answer for this one. This is a really nice Kubernetes 1.1 feature. It came out with a thing called a daemon set. So this is so that, if you want to be able to say, I want this pod to run on every node in my cluster, or even only necessarily maybe on some particular nodes on that cluster, which is also cool. So a daemon set is very simple. So the example I like to use here is if you want to run like a logs collection daemon on every node, like maybe FluentD or Logstash. Maybe you want some sort of monitoring daemon like New Relic or Prometheus, something like that. This is exactly the sort of thing you want to have.
Yeah, I see.
So pretty much by its simple definition, when you set up a daemon set, it covers all nodes, and you basically specify which container you want to run, and away it goes. It's pretty straightforward. It's pretty cool in that, in the same way that you can do selectors and attribute metadata on pods like you would do normally with replica controllers, stuff like that. So those control like whichever ones have those key value pairs. You can have those labels, those key value pairs on nodes as well.
Oh, nice.
So when you do a daemon set, you can say, I want it to run on the nodes that have these tags.
So I could say, for instance, I want to run Logstash, but only in production. Don't run it on QA.
Yeah, well, it's actually more about I want it to run more on the clusters that are on the left side of the room rather than the right side, like the actual nodes themselves, right?
Okay.
Yeah.
Oh, yeah, I see.
Yeah. So
interesting.
So it's really
so you could do something like, I want to run it only on the nodes that have some specific bug. Like you have like some kind of architecture and you want to just log that architecture, not the rest.
Yeah, so if you had a cluster with machines that are not necessarily the same, whether or not that's a good idea, that's a whole other topic of conversation, which is fine. But you might tag those as being those machines for various reasons. And therefore you could say, okay, I want to run particular stuff on those things and not on others.
Very cool. That's the kind of thing that it sounds like, of course. But once you're trying to solve that problem, if you don't know the name to look for, daemon sets.
Daemon sets.
That can be fun to find. Great. Well, before we finish with this podcast, where are you going to be?
So when this podcast comes out, I will be in Australia. Looking forward to that, seeing some friends and family. But getting back from there, I will be at the Launch Hackathon on the 26th of February.
Nice.
Looking forward to that. I will also be at the Game Developers Conference here in San Francisco. I'll be at the Google booth, so please definitely come by and say hello. We've got lots of interesting things going on there. I'm really excited about some of the content we're putting together. There's going to be some fun things happening there. We'll both be at GCP Next.
Yep.
Big conference for Google Cloud Platform. I think we're going to be doing some fun stuff there as well. And I will also be at the Strata conference as well on the 29th of March.
Very nice. So you're not going to be traveling that much other than for vacations.
Yeah, I think the furthest I go in Q1 is like San Jose.
That sounds...
It's weird.
Yeah, that sounds great. So...
You're everywhere, aren't you?
Slightly different case for me. Yeah, so on February 23rd, we'll be in GopherCon, but GopherCon Dubai.
Lovely.
Yep, so I'm going to be talking there. Very excited. I think it's my second time in Dubai. Last time I was there, I saw a very active community of developers.
Nice.
So I'm very excited about interacting with them again. After that, bunch of stuff. South by Southwest.
Oh, that'll be fun.
Yeah, Google Cloud Platform's going to be there. We have the Fiber Space. We're going to be running a bunch of stuff. We're going to be running parties.
Nice.
It's going to be lots of fun. Yep. And after that, in the GCP Next, I'll be back to San Francisco.
Cool. Well, then I will definitely be seeing you there.
Great.
In fact, that may actually be the next time we see each other.
Maybe we'll have to end up recording stuff remotely.
Yeah.
That's fun, though.
Yeah, that's fine. All right. Well, thank you very much for joining me yet again, Francesc.
Thank you so much to you, Mark.
All right. And I'll see you at least virtually next week.
See you next week.